Welcome back, everybody. Now we'll continue with the questions. The next one is B. That's actually question 2B. If X and Y are members of the universal set E, then the universal set E has elements 1, 2, 3, 4 up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. List the members of the following subset of E. That's the first question. Under number 2, that's question 2B, Roman figure 1. It says X and Y, set X and Y are members of the universal set E, and we know that the universal set E has elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the set X is described as having elements X such that X minus 2 is less than or equal to 2. That means the set X is the elements of the set X are 1 minus 2 is minus 1. Minus 1 is less than 2, but is not an element of the set E. So it can't be an element of the set X because it's not in E. We go to 2. 2 minus 2 is 0. 0 is less than 2. It satisfies this condition, but it is not a member of the universal set. It's not a member of this set. So that means 0 cannot be an element of X. We go to 3. 3 minus 2 is 1. I'm checking X minus 2. If it is less than or equal to 2, then that element is going to be a member of the set X. So 3 minus 2 is 1, and 1 is less than 2, and this 1 is a member of the universal set, and that means 1 is a member of the set X. Now 4 minus 2 is equal to 2, which is the same as 2, and that 2 is a member of the universal set. So 2 is a member of the set X. 5 minus 2 is 3, and 5 minus 2 is 3. 3 is greater than 2. So 3 cannot be an element of the set X. So that simply means the set X has elements 1 and 2, because its elements are less than or equal to 2. So it's either it's less than 2 or it's the same as 2. And the only two numbers that satisfy that condition are 1 and 2. So the elements of the set X are 1 and 2. Now set Y, that is described as Y such that 3Y minus 2 is greater than or equal to 19. So let's pick the first element of a universal set, 1. 3Y, which will be 3 times 1 minus 2, that's equal to 3 minus 2, 1. 1 is not greater than or equal to 19. So 1 cannot be an element. 2, if you pick 2, 3 times 2 minus 2 is equal to, that's 6 minus 2, 4. That's not greater than or equal to 19. We pick the next one, which is 3. 3 times 3 is 9. 9 minus 2 is 7. 7 is not greater than or equal to 19. We pick the next one, which is 4. 3 times 4 minus 2 is 12 minus 2, that's 10. 10 is not greater than or equal to 19. We pick the next one, which is 5. 3 times 5 minus 2 is 15 minus 2, 13. 13 is not greater than or equal to 19. We pick the next one, which is 6. 3 times 6 minus 2, that's 18 minus 2, which is 16. 16 is not greater than or equal to 19. So we pick the next one, which is 7. 3 times 7 minus 2 is 21 minus 2, which is 19. 19 is equal to 19, and they said and y is such that 3y minus 2 is greater than 19, greater than or equal to 19. So if it's greater than 19 or equal to 19, then the elements that gave us that will be an element of a set y. So that means 7 is an element of the set y. Now 8, 3 times 8 is 24. 24 minus 2 is 22, which is greater than 19. So that means 8 is also an element, because it was 8 that gave us 22 from universal set. Now 9, that's 3 times 9 minus 2, that's 27 minus 2, which is 25. 25 is greater than 19, so 9 is also going to be an element of the set y. 10, let's check 10 if it satisfies the condition. 3 times 10 minus 2, that's going to be 30 minus 2, which is 28, and that's also obviously greater than 19. So the elements of the set y are 7, 8, 9, 10. Now the question is, okay, list the members of the following sets, subsets of E. So we have listed the members of the sets X and Y. Or I've even answered 2 questions together. The first one is listing the members of the set X, and the second is listing the members of the set Y. So this is here, I already did that. Roman figure 1 is X, which has elements 1 and 2, and Roman figure 2, Y, which has elements 7, 8, 9, and 10. Now Roman figure 3 says find X union Y, find the complement of X union Y. Before we can find the complement of X union Y, we need to know the set X union Y. The set X union Y is the set which contains all the elements in X and Y put together, and the trick for that is write out all of the elements in X and write all the elements of Y without repeating any element that is already in X. So I'm writing out all the elements of X, 1 and 2, and the elements of Y, none of them is in X, so I'll just write all of them, 7, 8, 9, 10. So the set X union Y has elements 1, 2, 7, 8, 9, 10. Now what's going to be the complement of that? The complement of the set X union Y will be the elements that are in the universal set but not in X union Y, and those are 3, 4, 5, and 6. 3, 4, 5, and 6. That's the set X. That's the complement of X union Y. And that's it, very, very simply. So we go to the next, which is number 3. Number 3. In a school of 60 teachers, 32 speak Hausa, 25 speak Igbo, and 34 speak Yoruba. And each of the teachers speaks at least one of these 3 languages. If 11 speak Hausa and Igbo, 14 speak Hausa and Yoruba, and 10 speak Igbo and Yoruba. Question A, show this information using a Venn diagram. Question B, how many of the teachers speak all the 3 languages? And question C, how many of the teachers speak exactly 2 languages? Question D, find the cardinality of the set H complement intersection I intersection Y. That means you are using H, Y, I, H for Hausa, I for Igbo, and Y for Yoruba. Alright, first of all, 3A, we want to show that in a Venn diagram Yeah, we want to show the information using the Venn diagram, and this is what that will look like. Now that's a set. This is going to be the, let me move that to the left a little. Those are the sets, and this will be the universal set. This will be the universal set. Let me move the circle down a little. The circles down a little. Yeah, that's better. So this is the set H. The number of teachers who speak Hausa will represent the cardinality of H. That's 32. This is the set I for teachers who speak Igbo. There are 25, so the number of elements in it is 25. And this is the set Y for teachers who speak Yoruba, and there are 34. That means the cardinality of that set is 34. There's no teacher who doesn't speak at least one of the languages, so there will be nothing outside here. Now the universal set, let U be the universal set, and the number of elements in it is 60. That's the number of teachers in the school. Now 34 speak Yoruba, 32 speak Hausa, 25 speak Igbo, and each speaks at least one. If 11 speak Hausa and Igbo, that means the whole of this place represents the teachers who speak Hausa and Igbo. So that's a combination of those who speak Hausa and Igbo only, and those who speak all the three languages. 14 speak Hausa and Yoruba. That means the whole of this Hausa and Yoruba. This is Hausa and this is Yoruba. The whole of this is 14, which is a combination of those who speak only Hausa and Yoruba, and those who speak Hausa, Igbo and Yoruba. And 10 speak Igbo and Yoruba. This is Igbo and this is Yoruba. So the whole of this is 10. That represents those who speak out Igbo and Yoruba, which is a combination of those who speak only Igbo and Yoruba and those who speak all the three languages. So I can simply say, to show that information, I can simply say, let the number of teachers who speak all the three languages, which is this number of elements in the set H intersection I intersection Y, be X. If that's X, that means this space is X. I know that those who speak Hausa and Igbo are 11. The whole of this is 11. So that means this will be 11 minus X. Those who speak 14 speak Hausa and Yoruba. Hausa and Yoruba will be this, the whole of this. So that means if the whole of this is 14 and this is X, that means this will be 14 minus X. That's the number of teachers who speak only Hausa and Yoruba. Now if 10 speak Igbo and Yoruba, that's the whole of this place, and I already know that this is X. That means this place will be 10 minus X, which represents those who speak only Hausa, only Igbo and Yoruba. If 10 speak Igbo and Yoruba, this place will be 10 minus X, because the whole of this is 10. So it means if this is X, this will be 10 minus X. Now we have shown all of that using the Venn diagram. What's question B? Question B says, how many of the teachers speak all the three languages? That's simply saying we should find X. To do that, we need to represent all of the remaining portions in the diagram. If we do that, we'll be able to solve for X. So let me just copy the diagram and paste it there. Yeah, now that's a Venn diagram. This is the Venn diagram. I want to find X. So before I find I want to find this, which will represent those who speak only Hausa. This part, which will be which will represent those who speak only Igbo, and this part, which will represent those who speak only Yoruba. Now, I know that this part plus this part plus this part plus this part is 32. So that's what I need to find those who speak only Hausa. So let me call this A. Those that speak only Hausa, let me call them A. Those that speak only Igbo, let me call them B. And those that speak only Yoruba, let me call them that number C. So A will be equal to 32 minus the sum of 11 minus x plus 14 minus x. Or if you like, you can say A plus 11 minus x plus 14 minus x equals 32. You're still going to get the same thing. So that means A is equal to 32 minus x plus x is 0. 11 plus 14 is 25. And that will be 32 minus 25 minus x. My pen dead. Pencil. Oh, 1 second. The pencil just okay, let's take a few hold on a second. Yeah, 32 minus open bracket 25 minus x, and that's the same as 32 minus 25 plus x, which is 7 plus x, or if you like, x plus 7. So those who speak only Hausa, the number of teachers who speak only Hausa is 7 plus x. Now let's find B. To find B, we can B plus 11 minus x plus 10 minus x is 25. So you can say B plus 11 minus x plus 10 minus x equals 25. Or you say B equals, or you do it this way. I can say B equals 25 minus open bracket 11 minus x plus x plus 10 minus x. Minus x plus x is 0, and that simply means 25 minus open bracket 10 plus 11 is 11 plus 10 rather 11 plus 10 is 21, and then that's 21 minus x, which is the same as 25 minus 21 plus x, and that's 4 plus x. So the number of teachers who speak only Igbo is 4 plus x. Now let's find the number of teachers who speak only Yoruba. That is C. I can say C plus 14 minus x plus 10 minus x equals 34 to find C. Or the same way I did the rest. C equals 34 minus open bracket 14 minus x plus x plus 10 minus x, and that's equal to 34 minus x plus x is 0. That's 34 minus, and then 14 plus 10 is 24. So that means 34 minus open bracket 24 minus x, which means 34 minus 24 plus x when you open the bracket, and that's 10 plus x. So the number of teachers who speak only Yoruba is 10 plus x. Now the question is, how many teachers speak all the 3 languages? That's simply finding x, and this is what we do to get that. We say 7 plus x plus 11 minus x plus 14 minus x plus 4 plus x plus 10 minus x plus 10 plus x equals 60. That's the equation we need to solve to get x. This is a trick here, so that you don't write any of them twice. Write everything inside one circle, and write the remaining things outside that circle. If there is anything outside here, you write it and say everything equals 60. So I'm going to write everything inside the circle h first, which is 7 plus x, which is 7 plus x plus 11 minus x plus 14 minus x, and I'll write this, and this, and then equate to 60. That's how to avoid making mistakes. So that I think I need to paste a tiny image here. Okay, I know that this is 7 plus x, this is 4 plus x, and this is 10 plus x. So I can now say 7 plus x plus 11 minus x plus x plus 14 minus x plus 4 plus x plus 10 minus x plus 10 plus x equals 60. The whole of that will give you everything inside the rectangle. Let me check again. 7 plus x plus 11 minus x plus 14 minus x plus 4 plus x plus 10 minus x plus 10 plus x equals 60. Yeah, that's what we need to solve. The equation we need to solve for the value of x. Now x minus x is 0, x minus x is 0, x minus x is 0, and now we add the numbers. 7 plus 11 is 18 plus 14, that's 32, plus 4 is 36, plus 10 is 46, plus 10 is 56. I check again. 7 plus 11, that's 18, plus 14, that's 32, plus 4 36, plus 10 46, plus 10 56. That's correct. So that's 56 plus x equals 60, and that simply means x equals 60 minus 56, which means x equals 4. So x is simply 4. So therefore 4 teachers speak all the 3 languages. Now to the next one, which is question C. How many of the teachers speak exactly 2 languages? That would be number of teachers who speak only 2. These are the parts where we have only 2. Those who speak only Hausa and Igbo, plus only Hausa and Igbo, plus those who speak only Igbo and Yoruba, plus those who speak only Hausa and Yoruba. So it is this. That's what will give us the number of teachers who speak exactly 2 languages. So that's simply maybe I need to copy the diagram so I can see what I want to write. Copy. Let me paste that here and paste a tiny image. So number of teachers that speak exactly 2 languages. Exactly 2 languages will be equal to 11 minus x plus 10 minus x plus 14 minus x plus 14 minus x. And that simply means 11 plus 10, that's 21, plus 14, that's 35. 35 minus 3x, and that simply means 35 minus 3 times 4, that's 35 minus 12, which is 35 minus 12, which is 23. So 23 teachers speak exactly 2 languages. Yeah, the next one, which is question D, says find n h complement intersection I intersection y complement. This simply means the number of elements in the set h complement intersection I intersection y complement, and that set is a set of teachers who speak only Hausa. The set of teachers who speak only Hausa, and this is it. I think I already copied this, so I can paste it here. The set of teachers who speak only Hausa, and of course that is this. Only Hausa. What represents only Hausa in the diagram is 7 plus x. That's the set of teachers who speak only Hausa. And that's it. The set of teachers who speak only Hausa. Number of teachers who speak only Hausa is represented by 7 plus x. Maybe I should bring it back. Yeah, 7 plus x is what represents the teachers who speak only Hausa. So that's 7 plus x, which is 7 plus 4, and that is 11. That's 11. Therefore 11 teachers speak only Hausa, and that's it. Very, very simply, when you solve any question on Venn using a Venn diagram, it is always important to represent all of the portions inside the Venn diagram before you begin to answer whatever question is asked. If you do that, it will be very easy to sieve out the answers from the diagram. That's gonna be it. Thank you very much. Thank you very much for sparing your time. I hope you understood the concepts, and I see you in the next. Bye bye.